this book, The Knowledge Machine, is I think one of the best books I've read. I've got my copy here. One of the best books I've read in recent years around science and trying to understand how science works, right? The core issue that Strevens is trying to answer is, why is it that human beings have been observing the natural world for thousands of years with the same kinds of brains that we're carrying around today, but it is only in the last couple of hundred years that sort of science knowledge has sort of accumulated. And that's the core question he's trying to answer. I wonder, before you read the book or became connected with these ideas, what were your thoughts on that question? Anybody ever thought about it? Or
Yeah, I mean, I can say that me and Ram discussed this a little bit before. I also need to say that I come here a bit as an ignorant, because I didn't know about this initiative before. I never read books about science in specific before. However, I have a master's degree and I'm now doing a PhD. Actually, thinking about these things was not
fantastic.
much of practice to me. But in my idea, I thought that we had this scientific revolution almost as a tipping point. Like we figured out enough, and then at some point we went and we understood that we didn't know anything. In my head, this was the pivotal moment, was us realizing that in reality we don't know anything, and there's a lot of things that we don't know. And then we set out in this quest to figure out what was happening.
Interesting. So kind of a reaching a point of humility almost, of realization that we don't really understand the natural world. That's super interesting. Yeah. Anyone else?
I feel like it's very connected to our ability to measure phenomena and write them down.
Mhm.
Because yeah, like you said, I guess our brains didn't change that much over the last couple of thousands of years. So I feel like it's more related to that than maybe some sort of shift in paradigm, but I'm not sure.
Interesting. So it's a sort of technology, right? And that's certainly reflected in modern science, right? Every year or two, someone invents some completely new technology and it opens up things that we were not able to see before, whether it's a amazing telescope, beyond the Earth's atmosphere, or it's a new sequencing approach, or, all these different things. And that's certainly the lives that I've lived as a scientist, right? The scientific technological revolution. That's interesting. Yeah. What about the scientists themselves? What's your view of scientists? As you think of yourself as a scientist?
You're asking if they also had a pivotal moment, if they also changed in the scientific revolution or something else.
Yeah, and how they did science exactly, how they are, right? I mean, let's go take a little step backwards. What are the core characteristics of a scientist?
Critical thinking,
Mhm.
constant reevaluation.
Curiosity.
Mhm.
Ego.
Okay, yeah, you're not wrong. I would agree. Yeah. So, as we think about these first three chapters of this book, what Strevens is doing is setting the scene for his core idea, and the core idea is the iron rule, and we'll talk about that in the next session next month. But in these three chapters, he is kind of setting up the context, and there is an analysis of his work that says he uses the baby werewolf silver bullet structure. Has anybody heard of this before? There's a baby, there's a werewolf, and a silver bullet. Have you ever heard of this before? No.
No.
Anybody
No.
want to take a stab at what it might mean? It's a general structure for storytelling, right?
I guess the baby is some sort of point of interest, the werewolf is the danger, and then the silver bullet gets rid of the danger.
Exactly. Perfectly said. So in this case, the baby is scientific progress, right? Advancement of human knowledge. And unfortunately, the werewolf is a human frailty, the frailty of humans doing science, their imperfection. And the silver bullet is the iron rule, which we will talk about, as I mentioned, next session. So this session is really more about the werewolf. It's about the frailty, right? And so, one of the questions I have for you is, sort of Strevens characterizes scientists as warm-blooded organisms, his term, right? Um, and he tells some historical stories in the book, which are really fascinating, which I can tell you. I can summarize a couple of them quickly for you if you haven't had a chance to read the book. And they kind of illustrate the frailty of the scientist. So let me tell you one of those stories. There's a story about a man called Eddington. This is told on page, if you have the book and want to follow along, there's an interesting table on page 49 of the paperback edition. So Eddington was a physicist, and this is in the early parts of the 20th century. And he wanted to test which theory of gravity was correct, Newton's or Einstein's, right? And the experiment that they did was really not an experiment; it was an observation. So they used a solar eclipse to take pictures of the eclipse with the goal of measuring the position of stars that were close to the penumbra of the eclipse, right? And the analysis would reveal how much those positions were shifted from the expected, and that would be an indication of how much the light passing from the star past the sun and into the telescopes they used was being bent by the gravitational force of the sun, right? And the degree of perturbation, the two theories predicted different degrees of perturbation, right? I'm a biologist, so that's about as much sense as I can make of that experiment. And it seems kind of crazy. So what they did is they took two telescopes that were pretty good telescopes and put them on boats and shipped them off to two different parts of the world where the path of the eclipse was predicted to be. And then they took sort of multiple plates with these two telescopes, and then they measured the distance, right? And I mean, sounds like a pretty straightforward thing, right? And then they wrote their paper and published it. And if you look on that page 49, that's one of the tables of data that you can see in their paper, and you can obviously look up the original paper as well. Anyway, the bottom line is that the two telescopes gave two very different answers. One telescope gave an answer that was very close to the Einstein prediction, and the other one gave an answer that was very close to the Newtonian prediction, right? Now, what do you think Eddington did when he wrote up his paper?
I think he discarded the astrographic telescope, the Newtonian one.
Yeah, exactly. He kind of already knew that Einstein must be right, and so he came up with some reasons, you can judge whether they're good or not, on why the telescope that gave the Newtonian answer was wrong, right? Is that what we think of as good sort of hypothesis testing and hypothesis rejection? Is that textbook right there?
That does give me the icks indeed. I'm not sure if we would do something like this if someone would let it pass indeed.
Right. Exactly. I mean, it's so why do you think he did that?
I mean, I do think to an extent that it's an educated guess,
Yeah.
but of course it is a guess. But I guess those are also to some extent unavoidable, and especially if you have a lot at stake personally. So
Yeah.
yeah.
And
Yeah,
I think
I mean,
this is also difficult to repeat. So you couldn't do the same experiment again with the same assumptions to test.
Yeah, exactly. And probably really quite expensive, right? I mean, right? So, a lot of resources, time and money had been invested in doing these experiments. It was very public. And to publish a paper that says, we did all this work and we don't really know, probably wouldn't have got him. I mean, I don't think the publication landscape was the same then as it is now, but the modern equivalent is that would not have ended up in Nature, Cell, or Science, right? That would have ended up in the Journal of Unequivocal Results. Yeah, so that's one story. The other story that Strevens tells is the story of Pasteur and Pouchet. And that story starts on page 50 of the at least the US paperback edition. And that's another interesting story because this was about one of the core observations that Pasteur made, right? So the question was, how is it that inert and inert organic matter becomes alive, right? So you take the experiment that they were doing is they would take some hay, they would boil it in water, and then they would expose it or not expose it to the air, right? And Pasteur's observation was that you had to expose it to the air to get some mold or bacteria or whatever to grow, right? And then the question was, well, is it the air per se, or is it something in the air? And so they had these experiments, and they did some really interesting stuff. They did this experiment so that with a Pasteur flask, right? So you can seal it or you can open it to the air. That's the variable. And they went to like ancient libraries because all the dust has settled, surely. All the microbes, spores will have settled there, that kind of thing. Anyway, the key experiment in their mind was to go to the top of a mountain where the air was cold and clean, and then do this experiment. And so Pasteur went up to that mountain, and he had 8 flasks, and only one of them had stuff growing afterwards because and they were all exposed to the air. So his argument was that air per se was not enough. Just this 1 out of 8 presumably also had a spore. Now, Pouchet went and did the same experiment, and for him, all of his flasks started fermenting something, right? And so unequivocal data. So they went, they decided that they would use a tribunal that would observe these experiments, and sort of like a study section, like a grant review study section equivalent. And when Pouchet arrived in front of that, where they were going to perform this experiment, he noticed, of course, that almost all the people on the panel were Pasteurites, right? They were buddies and connections of Pasteur. So he said, I'm not playing in this playground. And they tried one more time in the same story, and he's like, I'm not doing it. And that was the end of the air hypothesis, right? And of course, Pasteur was right? I mean, organisms, right? Microbes, spores, whatever. But is that how science should be done? Yeah, I mean, it's like...
I don't like it. I don't think so.
Sorry, I couldn't hear that.
No. I'm saying jokingly as a tantrum that I don't like it, but this is me saying I understand why it played out that way, but I disagree fundamentally. I don't think that this is how it should be done. Indeed.
Yeah, and so I think, so how does that make you think about scientists as human beings?
Indeed faulty, right?
Yeah.
Non-objective, I guess.
Yeah, right. And when we think about, when we go back, when we think about some of the philosophers of science that Strevens also deals with in this section of the book, I don't know if you're familiar with Karl Popper. Anybody? Does the name ring a bell? Yeah. Go ahead. What do you remember about Karl Popper?
I mean, I remember this falsifiability idea, and I've read about it now as well, also before. So I think that's kind of the key principle. But I guess it's more sort of from a logical perspective that he says that you cannot really prove a theory, you can only falsify it. But I'm not sure if I see this necessarily as a social analysis, but I don't know because I haven't read him specifically.
Yeah, but that is at the core of his idea, exactly. The idea that you cannot really prove something, which scientists would agree, right? I mean, and so his idea was that you can try to disprove something, and if you fail to do that, and you fail to do that over time and with lots of effort, then maybe you're right. But tomorrow a new piece of evidence may come forward and would change. But his assignment, if you will, to scientists as a result of this philosophical point of view, is that he basically thought scientists should spend their time trying to falsify hypotheses, right? And the two examples that we just talked about, how do they connect with the sort of Popperian ideal?
Yeah, it's basically the opposite.
Yeah.
Sandra, are you unmuting? Would you like to join in, please?
Yeah, I think they were more focused on proving they're right instead of kind of unbiased, looking at indeed trying to falsify why is the other wrong, kind of.
Yeah, and why do you think that is? Why do scientists do that?
And they have their favorites, kind of, their favorite theories, their beliefs, their yeah, a lot below the iceberg, kind of.
Yeah. Yeah. So what Strevens calls that is auxiliary assumptions, which is a sort of, I think, a very kind way of putting it. Right? They're assumptions, and sometimes they're probably more than assumptions, right? In the sense that they're vested interests, right? So like we were talking about Eddington, right? Having shipped those two telescopes and traveled half the world and done all this stuff, right? There's a vested interest in the outcome. And I think it's, I don't know, when you think about the work that you do, I'm curious, how dispassionate are you about the hypotheses that you're investigating? Are you like, I totally don't care if this goes one way or the other? Is that an accurate reflection? And don't this,
I mean, I speak for myself. I think I am indeed very passionate, but I like outsourcing that critical ability to my peers. And I think that this is what also makes science a good environment, is that, okay, I might be unlikely to go against myself, but I expect my peers to go against me if they think I am wrong.
Interesting. So tell me more. Where does that dynamic unfold? Where do you experience that?
I do think that maybe in conversations, I do go there to test my hypothesis, and I might be very stubborn about what I'm saying, but but indeed, I think that I go there, and at least my thought process is, if after this conversation, this never happened, I'm saying this like but if after this conversation I had no opposition to everything that I say, that means that I'm doing a good job. If anything was brought up, then I need to think about this. At least this is my go-to, and then you can kind of prioritize maybe how much this opinion or this observation you want to really dig deep into, or maybe just accept that, okay, this is a I don't know sort of scenario, and I just need to point it very clearly that in this assumption, I am not sure, just for the sake of transparency. And I'm going with my assumption, but I have no basis to prove this.
So if you'd permit me to paraphrase and to check in with you to make sure I understood your point of view correctly, is you're saying it's okay for me to be subjective, maybe some little bit, maybe a lot, because the objectivity and the testing of my hypothesis is something we do as a community. Did I get that right?
Yeah.
Oh, interesting. That's a really interesting point of view. Huh. I wonder, how do others feel about that?
Yeah, I was thinking a bit about this, because then both of the examples you name of Eddington and Pasteur, in the end they were both right, kind of. So you can disagree with kind of the way it went, but apparently there was some consensus, and apparently if you put enough scientists in a room and they have a consensus, then I mean, yeah.
Yeah, there was definitely some consensus, and I wonder how do you think that consensus connects to the scientist who is leading the consensus? So in this case, Einstein and Pasteur.
I mean, of course, they have a lot at stake, I guess. And yeah, if we think in maybe more today's terms, if you're a researcher and you need funding and things like that, of course, you're more likely to push your narrative, because that's what in the end feeds you in a way. So yeah.
Yeah, I would say unimpeachably both of those scientists are amazing scientists, right? I mean, you cannot argue with the accomplishments of the two of Pasteur and Einstein, right? And likewise today, as you say, there's many sort of very famous and accomplished scientists. So clearly their skill and ability. What about their power? You know, is it a coincidence that the panels that were produced for the Pasteur-Pouchet discussion or contest, is it a coincidence that they were all Pasteur's people?
I guess not.
Yeah, yeah. So that brings us to the one of the other big theories in how science works, which is the Thomas Kuhn's idea of paradigm shifts, and that's a generally a more well-known concept. Have you come across that?
Yeah, it's in the first
Yeah.
chapter. Yeah.
Yeah, and so that really just reflects this notion that science does not progress linearly, but it sort of goes through periods of orthodoxy and a paradigm is established, and then there's revolution, and the paradigm is overturned to an extent, and it's, you know, a new paradigm is established until that. So that sort of it connects with Popper's idea of, you know, falsification. So at some point, the orthodoxy is falsified, and then a new orthodoxy grows up. But what's interesting is, you know, why do we need scientific revolutions? Why does it not progress sort of majestically, you know, at a steady pace?
Well, I think that's, at least in my perspective, a bit philosophical, right? That's thinking if we can, with one paradigm, indeed describe all of the phenomena around us. And I would say that at least there are some scientists that would believe that that is not the case, and we will never have a whole nice cohesive picture of things. And this is why we need sometimes to change paradigm to explain other phenomena that we are seeing.
Yeah, I mean, I think that makes a lot of sense, right? So a paradigm has a lot of advantages. It's particularly if it's a good one, right? It usually has, you know, let's talk about, for example, the central dogma of, you know, molecular biology, something that I grew up with and saw change because I'm very old. But, you know, there was a time when we thought exclusively DNA, RNA, protein, right? And then people discovered reverse transcriptase, and then it got more complicated, and then people discovered prions, and so then the whole thing is like, okay, but so of course, if you have the central dogma DNA, RNA, protein, that's a great explanatory framework. It's a great experimental framework. It's a great framework to communicate to people. It puts order into all the data and so on, right? So it's attractive.
Hmm.
Kind of also maybe like a loss function. Like we're as a scientific community are like stuck into some local optima, and kind of to get out of that local optima, you have to get over a hump and kind of have a new revolution to get into a new local optima probably.
Yeah, I think that's a really good visual concept, and I think that makes a lot of sense. So I'm old enough to have, when I was a postdoc at the Salk Institute, Stan Prusner came to give a talk. So Stan Prusner was the discoverer of prions and ultimately the Nobel laureate. This was before his Nobel Prize, and as you probably know by reputation, the Salk is full of incredibly brilliant professors, and they gave him hell. And the talk, you know, in the hallway afterwards was like, how can that be true? He's clearly missing something, right? I mean, it was all the obvious things. You know, did he do the experiment properly? Did he interpret his data properly, right? But it was interesting to observe the resistance to an orthodoxy that then was overturned. I mean, I didn't know it at the time that that would be overturned, obviously, but in retrospect, that was really, really interesting. Very human. Okay, so I'm going to come back to this question. We are warm-blooded organisms, and so how do you think? What do you think are the core characteristics of scientists? Have you added anything to your notion?
I'm very skeptical, I guess. We are very difficult to convince.
Right, right. That's true. That's very true. Yeah, yeah. So if we think about this sort of irreducible, if you permit, subjectivity that inhabits, I would argue, any person, right? So these biases that we bring, which are learned biases, and they're not necessarily bad biases, right? I mean, we would defend them. What is objectivity then? I mean, I love the model of outsourcing your objectivity. I love that. I think that's fantastic. You should write a piece about that, because
I didn't come up with it, certainly. Well, I'm at least I'm at a stage that I'm not sure if I believe in true objectivity in general. So I'm not sure if this is an unattainable goal that we are kind of deluded in chasing. So this is also why I believe I'm defending outsourcing the objectivity, because to me it's just compounding subjective perspectives maybe gives me a better picture of what is actually happening, of reality.
Yeah.
Or at least I understand the point that you're trying to make, but right now my biases are that this subjectivity is actually a good thing. That if we were truly less subjective about things, we would probably miss out on a lot more than not.
Interesting. Tell me more about that.
You're a biologist. Like sometimes I think about this ability of our brain to, like, we have to numb out a lot of things in our perception system so that we can actually get some information out of our environment. So in some sense, I do think that sometimes limiting can give you more direction in that sense. I'm not sure if I'm being a little bit too metaphorical in here.
No. I mean, yeah, go ahead. Sorry, please.
No. I'm thinking of maybe a completely tangent example, but writers sometimes use these abilities to actually produce something. You cannot start with a blank slate and that's it. You have to kind of limit yourself to some perspective, some lens, and then you can actually actuate on what you are doing. So if you have no subjectivity, how can you actually react to things that are around you and come up with new ideas or new things to deal with them?
Completely correct. Yeah. Are there any fans of The Hitchhiker's Guide to the Galaxy in the room? Anybody read those books? All right. Then you will know the answer to this question. The man who rules the universe, what is one of their core characteristics, most important characteristics? Do you remember that scene on that distant planet somewhere?
I'm not sure if I remember that, actually, unfortunately.
Okay, so very much in the late, I think, third or fourth book, at the end of the journey, I've read the book several times. Arthur Dent, I think, meets the man who runs the universe, and this man is described as, before Arthur comes in, discovering that he has on his desk a piece of paper and a pencil, and he discovers that he can make a mark on the paper with the pencil. And he's like delighted by this. He thinks this is wonderful. And then Arthur comes in, they have a brief conversation. And then as they're leaving, the man again discovers that he can make a mark on the paper with his pencil, right? And so it's exactly sort of the antithesis of what we were just talking about. This person has no subjectivity. They are pure objectivity. And they have no, just because the thing made a mark a few minutes ago on the paper doesn't mean it's going to do it again. So they're open to rediscovering something that they discovered just a few minutes ago, right? And of course, if that's how, I don't know, have you seen the movie Memento? The Nolan movie, right? So that guy lives in a 5-minute period of time, and it's very hard to manage. So he uses writing and tattooing and other interesting approaches to create the memory. But we as humans need that memory. That memory is how we evolved, and without it, we would be completely non-functional in the world, not necessarily as scientists, but just as human beings, right?
Yeah, there was also kind of this part about induction, and that kind of the idea of induction was based on induction, kind of, and that therefore it was not valid. I struggled kind of that you cannot like you have to do some induction, but yeah.
Exactly. And we're big induction machines, right? We're pattern sensing machines and we're storytelling machines. And we look at, which is why we're prone to conspiracy theories and weird explanations for things that aren't, right, that don't really hold up and don't really make a lot of sense, right? If something happens right after something else, we are very prone to think of a causal connection, even if it may just be coincidental, right? So I want to switch a little bit of gears now to how does this interface with night science, right? So you could take Strevens's werewolf, which is kind of what we're talking about here. There's all this human frailty, this subjectivity, maybe this intuition. You know, I just knew Einstein was right, so I made sure that that's what my paper said. When we think of the concept of night science, right, which is this counterpart to day science. So day science is pure Karl Popper, it's pure data collection, objectivity, empiricism, right? It's just all that good stuff that we pretend that we're the high priests of and really amazing at when actually we're sort of mixed. But night science accepts our human frailty, right? It says for creating hypotheses, for exploring new ideas, you may be frail, you may bring your subjectivity, you may bring your intuition, and you may bring all kinds of other thinking tools that Itai and Martin have described over the years, right? So we think night science is good, obviously, otherwise I wouldn't have that over my shoulder. And we think this is something to be celebrated and strengthened. But then at the same time, Strevens is saying that's the werewolf that's going to eat the baby of science. Thoughts? How does that resonate with you?
Maybe it is also a bit about like implicit and like if you are aware of your biases and assumptions, kind of that like in night science you also have to make yourself a bit vulnerable and go a bit outside of your box and kind of dare to. So at some point, I believe in the book they also said like that the true scientist can only argue one side of a debate, or I don't know where they said it or who said it anymore. Which I found a bit, yeah, I think like in science, but then maybe it's more in night science. Scientists could actually argue both sides, or at least understand both sides of the debate, as long as it's not really fundamentally disproven. Kind of, you should be able to at least reason.
Yeah, I think that's really well observed. I agree with you. If we were pure sort of machines of rationalism, then we wouldn't be able to see two sides of something. But because we're not, we are actually able to do that. And that might even open up opportunities. Yeah. And you've also sort of touched on this idea of awareness of biases and weaknesses, right? So that's a big part of what we do in our night science workshop is we try to help people recognize what kind of a brain they have in this context and the what that brings with it, like we just talked about, right? It's great for survival out there in the in the world that we evolved in. Maybe it's not so great anymore here in 2025 with social media and all that stuff. That's for for another day. But thank you, Sander. Anyone else thoughts on this sort of interface between human frailty and night science and creativity in science?
Yeah, I was also about to say something similar. I think that I think in my line of work, I might be aware of 12 assumptions that I make in order to reason about things, and maybe 4 or 5 of them I can test myself, and the other 7 I would need either external data sets for or things that are just not out there in the world. So I always have to keep this in mind during day science, and I find it sometimes difficult to progress. So from a practical standpoint, I'm sometimes bottlenecked by this. And then in the night science practice, I can sometimes trust more on my intuition and say, trust a few of these assumptions. And actually, I'm gonna now in the Wild West build upon the few things that I think are correct and do some analysis that might jump the project further a bit, and without being held back by this very strict and critical point of view that I have during day science.
Yeah, thank you. I mean, that's really, I really appreciate you saying that. So what you described is sort of a sense of control over this sort of right acknowledgement. And I'm curious, the assumptions that you mentioned that you use for a particular piece of work, are they all explicitly Like, are they explicit? Are they written down somewhere, or are they commonly accepted, or are these just things you're aware of that you're bringing to the project?
I think 5 are relatively explicit in the sense that every paper in this field has to comment on at least these pre-processing steps, for example. But there's no consensus there. So it's even we have these 5 choices, and papers can differ within these 5 choices. So that's interesting. And then maybe the other 7 are pre-analytical variables that are considered or about the data gathering, for example. And then I think there's one paper that really goes explicitly into testing what's now the influence of these pre-analytical variables or confounders on the final results, but that is a paper from 4 years ago, the first one in the field, and maybe now there's a few more coming out. Yeah, so relatively explicit, at least for me in my head or in my notebooks, they are very explicit.
Okay.
It does make progress slow sometimes for me because
I
it's
can
difficult
imagine.
to conclude. Yeah.
But someone who understands the art of your work would be able to understand these assumptions, and they might disagree, but they'd be able to understand them. So that's very powerful, right? I mean, that seems to me very acceptable, and in terms of the sort of even the pure day science, Popperian scientific method, right? I mean, you can't, assumptions have to be, we make them every time we choose a model or choose an experimental approach, right? Yeah, interesting. Yeah. So if scientists go ahead.
Can I comment on one last thing?
Please.
I would say that coming from also a bit of a biological background in my experience, I think assumptions was something that I really had to get used to. And this was kind of satirical at some point when in training that you would start to you have this very, very critical thinking of you have to explain everything that you do. And then at some point in your academic career, you are pushed to make assumptions, and you kind of go into this like, okay, if you don't know something, assumption. If you're not sure, assumption. And then you kind of start mocking this a little bit, and like you can use it and abuse it kind of. And I think what I learned throughout the years was, indeed, I think that the habit of listing them out explicitly, this is something that we were trained to do, actually at some point satisfied me quite a lot, which is to say, okay, I'm exposing to the world that indeed these are all of the things that I have no clue about, or at least maybe I have a clue about, but I didn't take the effort in going very deep into them. And like, if you doubt anything that I say afterwards, this is probably the first thing to look at and to start shooting at. So I think it provides a framework that is really nicely to then go and again, maybe as what we would say, criticize very much. But I don't know, I like the idea of assumptions, and I thought it was peculiar, this arc of finding them very lazy and very cheating in some sense, and then at some point thinking as them as, no, these are very pivotal so that we can actually do work.
Correct. And I think if they're explicit and justifiable, right? I mean, that's great. The risk comes if they are hidden and perhaps not so justifiable, right? And that's kind of where this is. So my final question is this sort of human frailty, essential subjectivity that we talked about, right? I put it to you, and I would love to hear your comments, that in day science it's a risk, right? Because of what we talked about. It can lead you to publish papers like Eddington. But in night science, it could be a strength, right? Because it could open up intuition and just, also as if you're familiar with the night science ideas, right? Metaphor and other kinds of cultural and emotional thinking tools and pathways that you can leverage, right? So do you agree?
Yeah, I think like assumptions can create like stepping stones to kind of scout kind of that certain area before we start like building a proper bridge to that place. Like see like, okay, does this even make sense? Explore a bit, and then in hindsight you have to go back and okay, did these stepping stones actually make sense?
Yeah.
Yes, that it allows you to go a bit further beyond. Yeah.
I love that, and I thank you for that metaphor. That's a really powerful metaphor. I mean, Jacob talks about night science being an exploratory, way of being, a way of thinking, right, and a sort of a mental state of exploration. So, I think that's you said that really perfectly. Thank you. Yeah. Any other comments? Okay. So next session, we're going to get to the heart of the book, which is the Iron Rule. So, we all love the baby. That's where we live. We cosset this baby daily, right? This baby of science. And now this big werewolf of our own frailty has appeared. So next session, we're going to focus on the silver bullet, the Iron Rule, which is pretty interesting and has a lot of implications, and I think has some interesting connections also to night science. So.